But when I come to exposome analysis, my data is not fixed. I have to look for exposures, lifetime exposures. Now, how much exposure I did had with what kind of environmental factor, that counts. So my data has the time scale also, where this data doesn't have the time scale. This is static data, and now my data becomes temporal when I talk of exposome. So at what time, how much temperature was there outside, or how much water contaminated was there, how much environment was polluted, all those things, all that data is replacing here. From that data, I am interested in looking into the phenome. So the exposome analysis problem is more complicated than this problem. Again, the modeling is going to help certainly to some extent. So future next of bioinformatics was people started talking of genomics, then proteomics, then metabolomics, then phenomics, transcriptomics. So many omics have come up here. And today you go on the website of the omics, you will find about 100 ohms, such type of areas. Now if 100 ohms have come up, what is going to happen to biotechnology? In MSc you study genomics one subject, proteomics as another subject, then metabolomics as another subject. So many 100 subjects will come up. What is going to happen to biotechnology? And then again this biotechnology will be redesigned. You will have MSc genomics, MSc proteomics, and MSc metabolomics, and so on. So we are moving towards super specialization. This is what is the trend which is happening. And again, when you talk of genomics, so it is genome informatics. You talk of proteomics, then proteome informatics, and so on. You talk of exposomes, so exposome informatics, and so on. Every ohm has its own characteristics, own relationships, and according to that, our informatics also has to change, adjust to generate the information and knowledge which is required for various decision-making purposes, for health and medical and so on. So, or agriculture or energy, whatever it is, applications are there. So for that we have to accordingly synchronize our informatics techniques too. But the major problem today is you cannot assess a phenome directly on the basis of genome or directly on the basis of proteome. That means you have to map the data at all these ohms to come to the right conclusion. But again, the problem is that you have large amount of data at genome level. The data at proteome level is just 1/10 of data available at genome level, and the data at transcriptome level is again 1/10 of that, and the data at metabolome level is again 1/10 of that, and so on. So the data size is data size is very less to perform the predictions at other levels of ohms, and that's why the mapping of the ohms is not possible till date, and therefore people are looking for shortcuts. Can I map the genome to proteome and proteome to phenome? Just because other data, I do not have complete data sets, and so we are having predictions. So certainly they will have the errors also, modeling errors will be there, because if data is not available or data is incomplete, that's leading to the uncertainty. So many informatics have come up accordingly, chem informatics, medical informatics, health informatics, and so on. And this chem, medical, health, clinical, and all bioinformatics, they are all combined if you want to perform exposome informatics. Biomedical informatics, everything is being combined into all these things. So you have to work at all these levels if you want to go for exposome analysis or exposome informatics. So these were the early tools, unlocking biological secrets. You have XPASI, Swiss model, Geno3D, CPS models. These were developed early bioinformatics, but they are still in use at the biological level or molecular level, and certainly in exposome informatics you are going to use them also. because you have to study at the proteome levels and protein levels and genome levels some data. Apart from this data, you have to add data from databases, epidemiological databases, environmental databases, which Professor Bhattacharya will be telling you all those data. Then we used to perform drug design, and we studied absorption, distribution, metabolism, and elimination of the drug. We were studying with the help of so many tools have been developed for this, and we have been doing it. But this was being done for drug development. But now, when from the environment the toxic elements are coming into your body, how much is absorbed and how much is eliminated, that has also to be assessed. So for how much time you had exposure to toxic chemicals, how much was absorbed, and how much was distributed, how much was metabolized, how much was eliminated. Same things now you have to do at the exposome informatics level or exposome analysis level. This is what is to be done. So now the data for this purpose is on time scale. Earlier for drug design, this data was not on a time scale. It was not temporal, it was static. But now it is going to be time scale because you are measuring the exposure also. It's based on the measures here. So the differences of data, and accordingly these tools have to be modified. We have to understand those dynamics based on this. So many databases came up for bioinformatics, and I'm not going to these details, you all know about it. So early people said bioinformatics plus biotechnology concept. This was the early definition which was given, people were talking of. Then so many databases in bioinformatics have come up. These are the basic ones I am talking of, you all know about it now. They are popularly used by most of the biologists, and the same are going to be used in your exposome analysis, because if you need analysis at molecular level, then these have to be used certainly. So these have to be the part of your exposomes analysis. Then homology modeling, there were tool which was developed, then protein data bank and all those things. So these were all developments in bioinformatics. Now what is going to happen now? When bioinformatics came, people talked of personalized medicine. And at the time, if you go, so doctor will ask you to go for a genome map and then he will prescribe the medicine. This was the concept which was becoming popular, and we have already moved, now people look for this genome map. So at that time when it was the beginning. So whenever there is a beginning of any technology, there is an advertisement. For one genome map, you get one free, 1 plus 1 free. So you get the offers like this. Now this is going to happen now next in the exposome also. So you go for exposome map. If the technology of exposome map will come up, and it's not completely come up, developed. When it will be developed, you will start getting the exposures, this all offers for this. Now you can see in the market, there are people who perform brain mapping. There are equipments from that you can have the brain mapping, and there are psychologists. So rich people, they take their child for brain mapping and ask them to questions that how my child will fare and in the exams, and how he will fare in his life, and what will be his personality and how he will develop. So a lot of people are earning a lot of money, and there are again a lot of offers also in the market. Even in the Bhopal also you can see there are there. So similar things are going to happen now in this. So once the human exposome mapping technology is developed, this is going to happen. This is one what I think. So these are some of the projects which are taking up shape now. People are working in these areas. The human genome has characterized some fundamental approaches in medicine. We talked of you go for genome map and we will go for personalized medicine. According to your genome, we will give the medicine. Okay. But then it was only the half part of the story. Genome is natural. But what is the remaining part is 70% the environmental factors. This only 30%. So we have uncovered this 30% part also not completely, and we are now exploring the remaining 70% part. So biological markers, we are looking for biomarkers now, and we want the person's lifetime exposure to nutrition, what type of food he is taking, food habits, bacteria, viruses, environmental toxins and so on, which are going to affect your health. So this is a big way this project is taking shape now. Then synthetic biology, we are looking for development of synthetic organisms. We want to develop a super bug who can go in my stomach and kill all the bacteria which is harming me. So this is what kinds of things are. It can direct the, say you have a cancer cells. So in cancer cell the apoptosis is absent. Can I put a super bug inside the body which can activate the apoptosis and the tumor is killed? So these type of things are happening. That means why apoptosis has stopped? Because inhibition is missing. And why inhibition is missing? That signal it is not able to receive. And that signal is basically a chemical signal. Therefore, can I devise a super bug and put into my body which can restore that signal back. So these type of relationships people are studying and then performing experiments on these things. So this again a kind of your exposome projects also. Breast cancer. What are the causes of breast cancer? A few genes are implicated and they account for only 10%, 5 to 10%. There is a story given, you go on the site of Emory University's Hercules Center. This lady, Jenny Singleton, got breast cancer at the age of 48. And her mother got cancer at the age of 66. There is a difference between the two. And when they got the cancer diagnosed, when you have breast cancer, you start saying that the BRCA gene is responsible for breast cancer, and you start getting test your whether this gene is present or not. That was the way of diagnosis earlier, but now it's not successful. It failed. So these ladies did not test for BRCA gene. They didn't have the gene. Then also they had a cancer, breast cancer. So this prompted to the questions, why breast cancer when BRCA gene is absent? If BRCA gene is present, it doesn't express, that's okay. But if BRCA gene is not present and then also you have breast cancer, is there any other gene for that response? Or it is purely due to environmental factors? She did not have any history, or purely, both did not have that history. So this is the question. That means the answer people are looking towards exposome. Can the analysis of exposome give answer to this question? So what is the challenge? The challenge we are looking for is, what are the environmental factors which lead to cancer? That means what are the toxins in the environment which are causing cancer, say tobacco, so on. So many things are there. So these are some of the databases for exposome informatics. There is a toxin target database, T3DB. Professor Patrick will be telling you about so many databases. Then blood exposome database has been developed. Phenol Explorer has been developed. CEBS is the toxicological data. So now these databases are coming up for exposome and you will be having plethora of data with you for analysis, and the challenge will be how this data should be analyzed to generate the new information and knowledge which can lead to that human exposome map technology. Okay, this is what and you can assess what are the reasons for these kinds of things. One of the research recently I was looking through the paper. One child got autism, and they found the reason for autism was high metal content, and the child used to put metal in his teeth, and from that metal has gone into his body, and that has led to autism. So long exposures to metals is one of the causes of autism. This is what has been discovered. You will find some people, go on the website, you'll get a lot of plethora of information. A number of tools have come up. You can go into details of the tools in your on the site, and Professor Patricio will be also be